A cricket ball is thrown at a speed of 28 meters per second in a direction 30 degrees above the horizontal. Calculate A. The maximum height, B. The time taken by the ball to return to the same level, and C. The distance from the thrower to the point where the ball returns to the same level. A. Maximum height h is equal to V0 square sin square theta 0 upon 2g is equal to 28 whole square into sin square 30 degree upon 2 into 9.8 is equal to 784 into 1 upon 2 into 9.8 into 4. Therefore h is equal to 10 meter. B. Time for flight Tf is equal to 2V0 sin theta 0 upon g is equal to 2 into 28 into sin 30 degree upon 9.8 is equal to 2 into 28 into 1 upon 9.8 into 2 is equal to 2.857. Therefore Tf is equal to 2.9 second. C. Range R is equal to V0 square sin 2 theta 0 upon g is equal to 28 square into sin 60 degree upon 9.8 is equal to 784 into root 3 upon 9.8 into 2 is equal to 784 into 1.732 upon 9.8 into 2 is equal to 69.28 meter is equal to 69 meter. A cricketer can throw a ball to a maximum horizontal distance of 100 meter. How much high above the ground can the cricketer throw the same ball? Question mark. Now range R is equal to U square sin 2 theta upon g, but for R is equal to R maximum theta is equal to 45 degree. Therefore R is equal to U square upon g sin in bracket 2 into 45 degree bracket over. Therefore 100 is equal to U square upon g. Equation 1 where R is equal to 100 meter is given. Sin 90 is equal to 1. Now H is equal to U square sin square theta upon 2g. For H is equal to H maximum sin square theta is equal to sin square 45 is equal to 1 by 2. Therefore H max is equal to U square upon 2g into 1 half is equal to 100 into 1 half from equation number 1. Therefore H is equal to 50 meter. The ceiling of long hall is 25 meter high. What is the maximum horizontal distance that a ball thrown with a speed of 40 meter per second can go without hitting the ceiling of the hall? Question mark. Initial velocity where u is equal to 40 meter per second, h is equal to u square sin square theta upon 2g, h is equal to 25 meter and g is equal to 9.8 meter per second square. Therefore sin square theta is equal to 2 into g upon u square into h is equal to 2 into 9.8 into 25 divided by 40 into 40. Sin square theta is equal to 0.3062. Therefore sin theta is equal to 0.5534. Therefore theta is equal to 33 degree 36 minute. Implies that 2 theta is equal to 2 into 33 degree 36 minute is equal to 67 degree 12 minute. Now range R is equal to u square sin 2 theta upon g. Therefore R is equal to 40 square into sin 67 degree 12 minutes divided by 9.8. Therefore R is equal to 1600 into 0.9219 upon 9.8. Therefore R is equal to 150.51 meter. Second method, sin square theta is equal to 0.3062 as found above. Sin theta is equal to 0.5534. Cos theta is equal to under root 1 minus sin square theta is equal to under root 1 minus 0.3063 is equal to under root 0.6937 is equal to 0.8329. Now range R is equal to u square sin 2 theta upon g. Therefore r is equal to u square into 2 sin theta cos theta upon g. Therefore r is equal to 40 into 40 into 2 into 0.5534 into 0.8329 upon 9.8. Therefore r is equal to 150.50 meter.